Let's look. Let's say we have the choice of whether we have momentum or not. Okay, no or yes. Momentum, remember, is the use of the v. And then an adaptive learning rate, where we have a learning rate per parameter, and that's our e. Okay? So if we have neither of these, this is our stochastic gradient descent. And we have a single hyperparameter for that, which is lowercase lambda. If we go ahead and add in momentum, then we get SGD with momentum. And in SGD with momentum, we have, again, our lambda, and we also have beta, which is basically how strong the momentum is. If we have momentum, then we can have Nesterov. That's optional, okay? But it requires momentum. So over in the no momentum with the adaptive learning rate, we have got as, let's look at eta grad. Remember, eta grad uses the total history. And so here we've got, for this entire box, we've got capital lambda, which is our base learning rate, and also epsilon, where epsilon is the factor we use in the denominator to ensure we don't have a zero. It turns out sometimes this works much better if that epsilon is not really, really small, like you would think, 10e to the minus 8. Sometimes 10e to the minus 1 works better for that value. And then we also looked at RMS prop, where normally the M and the S are capitalized to evoke the root mean squared error. And here we're using an exponential moving average, the history. And this is the history of the squared gradients. Here we add in, so we still have the lambda and the epsilon for this whole group here, but then we also add in gamma, which is what to use for our exponential moving average. Okay, what constant to use for our exponential moving average. And then the combination of both momentum and adaptive learning rate is atom. So we've basically got, we're still using the exponential moving average of so here in our momentum case, we're using exponential moving average of, but here we're using both. And so we've got the combination of all of the parameters, except we no longer have the lowercase lambda. Okay? Instead, we use this uppercase lambda here, okay? Which is our base learning rate. We can add Nesterov again to either of these, and then we can also add look ahead to any of these optimizers. I think of it less as adding look ahead and really wrapping. So I kind of look at it as look ahead of atom, let's say. So atom is our slow optimizer, and this is look ahead. Yep. One way to think of it is we're just passing as a parameter to look ahead, which is the optimizer we want to be using as the fast optimizer. And then look ahead will be acting as the slow optimizer. So that's our overall picture of the various optimizers. The only other thing to remember is we do have some particular names. So atom plus Nesterov is natom. Look ahead plus a rectified atom is ranger. The other one we actually have in here, we can add weight decay. And also, why don't we just put in here, we've got hyperparameters. So here we have hyperparameters alpha and k, and we can add weight decay to any one of these. And so weight decay can go to any optimizer, and let's say the hyperparameter is delta. So as we are creating an optimizer, we might choose, for instance, to use look ahead on atom with weight decay. So we would need to be providing alpha, k, delta, lambda, epsilon, gamma, and beta. It's a large hyperspace to search through to find the best set of parameters. Having a good set of default values is useful, and FastAI has some good defaults for each of those. So that's optimizers.